to open something else. Yeah, so just a reminder that the quiz number 2 will focus on parts of week number 3 and week number 4, which we will cover today. And then part 2 of consciousness, conscious states. I did talk about it when I talked about biological psychology and states of consciousness, and I talked quite a bit about consciousness and sleep, which is a state of consciousness, and really, like dreams, for instance, is a different state of consciousness, or you could say altered state of consciousness. And here, under consciousness and biological psychology, part 2, you will. There's another lecture note on states of consciousness that are changed not only under dreams, but hypnosis and prescription drugs and illicit drugs. So I will, you can go over that. I mean, you should go over that, but if time permits, I will cover a little bit of this, which is in conjunction with, or a continuation of what we talked about in week 3 when we talked about biological psychology and consciousness. But the focus today is on sensation and perceptions. So anyway, quiz number 2 and then test number 1 when you come back after your break. I will give you more details, or I will give you more information about it, but it will basically focus on the first 5 weeks. So on everything that we have covered so far before your engagement week break. So basically the first 5 weeks. And I decided to give you more time for the quiz, and you have also 2 attempts. But it will be the same scenario where you get a whole bunch of a list of concepts, and you fill in the blanks based on your knowledge and based on the concepts that match statements. Are there any questions about that?
No.
Okay. Okay, so let's, any questions in regards to last week's content? Anything that, any questions, anything that was unclear, or something that was really interesting that lingered in your mind, or something that happened over the week that was related to some of the content that you would like to talk about or bring up? Any examples, anything in reference to what we talked about last week or thus far since week 1? Something peculiar, interesting, or unusual that's related to psychology, maybe, that you want to discuss briefly or ask questions about?
Can we collapse 2 minds or more than 2 minds into the one?
2 minds into one? No.
Oh, that's it. Okay.
Why would you think that?
I was watching some kind of sci-fi movie, but some kind of sci-fi movie is just collapsing a lot of mind into the one, so they can build some hive mind which controls a lot of entities of beings, I guess, or living things. So I just wondering, will it be possible or not?
Yeah, that would be very difficult or nearly impossible. But I mean, considering that the left hemisphere and the right hemisphere work together and in one brain, I mean, and yeah, they compose one brain functionally, right? And since the brain functions together, or various subsystems function together to give rise to one consciousness or one mind, then theoretically that is possible, right? On paper, I guess that's possible. And again, but in practice, I don't know, that would be very, very difficult. Yeah. But anyway, we'll leave that to filmmakers and science fiction writers to figure out one day, but who knows? You never know, right? Yeah, good question. Yeah, I like science fiction as well. Okay, let's, so I'm just going to go to the lecture notes. Okay, so today in this lecture, we will focus on sensation and perception. And there's a big difference between sensing information and perceiving information. Any ideas what is the difference between the two? Why would sensations be different from perceptions?
I think it's difference between physical and psychological properties, I guess.
Yeah, not bad. Could you elaborate? Could you say a little bit more?
Sensory singing or sensor seems or sounds more like something that you can feel according to your outer feature, but in opposite way, perceptional properties sound like or seem like something that you have to do inner side of your body, which means brain. Oh yeah, brain.
Okay, so more or less, yeah, more or less that's true, and more fundamentally, sensation is about collecting information from the outside world through the body, or from the interior milieu of one's body. But then there's the process of taking that information, sensory information, and turning it into perception. So just because the body collects information from the outside world, let's say through the visual system or the tactile system or the olfactory system, smelling or tasting, that doesn't mean that the sensory information will make it to a perceptual whole or perceptual understanding of what's happening. So, and there's also information that we process subliminally or unconsciously. And I will give you examples of that. And it's also true that that the context or motivation and emotion shapes what we perceive. And I'll give you examples of that as well. Okay, so let me just go back. Okay. So sensations are mainly about the process by which the sensory receptors and nervous system receives and represents stimulus energies from our environment. Okay, so whether you're looking at something, whether your eye is looking at something, or whether you are touching something, or whether you are listening to something, or whether you are trying to smell something or taste something, that is basically that is basically information that goes through your sensory receptors. Okay. Oh, sorry. So we have specific sensory receptors, let's say in our eyeballs and in the visual system, that then that then translates or transduces information from energy that's on the outside of our bodies into neurochemical information, and then the neurochemical information turns into perceptual or conscious representation. Okay, so there are really 3 stages. So sensory receptors are sensory nerve endings that respond to stimuli, let's say light, which is electromagnetic energy, right? Or sound waves, or chemicals in the air that get into our noses, and then we have a sense of smell. Because of that, okay, so we have specific sensory receptors to pick up information from the outside world through the 5 modalities or senses, and that triggers specific sensations, which then trigger specific perceptions. So when you smell something, you will have an immediate sense that there is a difference, that your nose receptors are stimulated, and you detect some sort of information through olfactory pathways or nasal passages, but you might not know exactly what it is that you're smelling. That may come a split second later, and then you recognize what the smell is. So you say, oh, that's a burnt smell, or that is a smell of something cooking, something specific, maybe tomato soup, or maybe a kind of meat, or maybe something, I don't know, whatever it may be. You go to a store and you try to pick out a perfume. That will trigger specific sensations, and those sensations will trigger specific perceptions. And then you can say, once you have a specific perception, then you can say, oh, this smells like cinnamon, or this smells like milk, or this smells like burnt toast, or this smells like, I don't know. You say, oh, it smells like the fall. Now we are at the beginning of fall season, and the fall season has a specific smell to it because the environment is changing. But when we say that it smells like fall, we associate specific smells or specific stimuli in the environment with our memories or our expectations or our emotional coloring. But especially with our memories and expectations. And then we have a percept, we perceive. And the perception that we enjoy is loaded with a lot of information. It's not only loaded with the information from our sensory receptors, but it's also loaded with information from the bank of information that we carry inside our brains. So our expectations, memories, and the like. So that is basically the process of perceiving something. We go from the human body, and the human central nervous system goes through collecting information from the outside world through sensory receptors, that then changes into simple bits of sensations. And once sensations that are traveling through neurochemical pathways in the brain get to specific representational maps in the brain, then when that happens, then you enjoy specific perceptions, okay? And then you can identify what it is that you're perceiving. whether it's a smell or whether it's a moving object. Oh, I know that is a car, or that is a bicycle, or that is a squirrel, as opposed to that is a dog. And that happens very quickly, but the brain requires specific amount of information to identify an object, let's say a visual object, accurately or correctly. Before that, you just have a sense that there's something moving in the environment, but you don't know whether it's a dog or a squirrel, or whether it's, or what color of a car it is, or how fast it is moving. But once you pay more attention, that is, once more information is gathered and represented by the brain, then you can make a much more accurate, you can enjoy a much more accurate perception. And therefore you can categorize quite accurately what it is that you are smelling or what it is that you are looking at. So again, perceptions are different from sensations. Okay, it's the process of taking physical information, light information, or sound wave information, or chemical information from the outside world, and turning it into psychological perceptions. And the magic takes in the central nervous system. And you enjoy the end products, or the effect of the whole process in your consciousness. Any questions here? Okay. So the processing of information goes through two pathways, or I should say there are two pathways that human beings use in order to generate perceptions, pathways of information processing. So the first one is bottom up, and this is a quick analysis that begins with sensory receptors and works up to the brain's integration of sensory information. Okay, so for example, again, the example of you catch something in your periphery vision, you don't know whether it's a dog, a squirrel, or maybe a rabbit. There's a moving object to your left or to your right, or quickly passes over your head, and then once you pay a little bit more attention to it, or when you turn your gaze to it, or your vision or your hearing, then that allows you to collect a little bit more information, and then you can say what it is. So basically you're building up a perceptual set, if you will, from the bits and pieces of information in time. Now, top-down processing, so that's bottom-up processing, like building a house, basically, bottom up. And then when you're done with all the bits and pieces or information, then you know that it stands together as a perceptual set, or but it needs to be constructed, basically, based on the information that you are exposed to or you pay attention to. Now, top down is when you give your sensory information that then becomes turns into simple perceptions, meaning. Okay, so this is called top-down processing. When you impose meaning, you impose order, on information that you gather from the external world. And imposing here means basically top down, and this means that your expectations, assumptions, and information and memory play a factor in determining what it is that you see or what it is that you understand to perceive. So information processing is guided by higher level mental processes, such as expectations, motivation, emotion, and memory. So it draws on one's experiences and expectations. So again, steps that are basic to sensory systems is first you receive sensory stimulation from the outside world in a form of energy, okay, that exists in the outside world or the environment. And then you transform the stimulation into neural impulses that are really neurochemical, as you remember, when we looked at the anatomy and function of neurons and synapses. And that is then transformed to stimulation into neural impulses that then become specific perceptions. Now, some information from the outside world is registered by our nervous system or by us, and some information is not. And we all have thresholds for sensing or registering whether we are aware of information or whether we are unaware of information, or conscious or unconscious. So you can measure an absolute threshold below which information is subliminal, and over which information becomes conscious, or unconscious and conscious. So basically the definition is minimal stimulus energy needed to detect a particular stimulus 50% of the time. So again, subliminal means below an individual's absolute threshold for conscious awareness. So it's basically the difference, 50% of the time, the difference between hearing something and not hearing something, seeing something and not seeing something, smelling something and not smelling something, tasting something and not tasting it. And it's not just with human beings, other animals have thresholds, and in some animals the thresholds are higher, in some animals the thresholds are lower. So for example, as you probably know, dogs have a very acute sense of smell. So in dogs, the absolute threshold for olfaction or smelling is much lower, let's say right here. But for human beings, it would be much higher because our sense of smell is not as sensitive. But for dogs, is the dominant sense, and that's why for human beings, the dominant sense is vision. Although the other senses are also very important and collect a lot of information from the outside world, and we have specific representational maps in the brain to represent and create or generate conscious representations of the information, of sensory information from the outside world. But for example, in animals like dogs, or visual information for animals like birds, such sensory information or sensations are dominant or dominate their nervous system. And that's why dogs use their sense of smell on a regular basis. And the first thing that they do is they smell things. And vision is also important, but it's not as important, and it's not as quick, and it's not as versatile, and it doesn't generate as rich of representations as olfaction or the sense of smell does in dogs. Okay, so individuals can also be affected by subliminal information. So the brain, as you know by now, and I have talked about this previously, processes information subliminally. That word is a mouthful. Subliminally or unconsciously, and also consciously. Okay. So subliminal information is stimulus that are so weak that people do not consciously notice them. But just because information is not consciously noticed or reported, that doesn't mean that it's not represented. It doesn't mean that it's not processed in the brain. Okay. So researchers can use priming to activate unconscious associations. So, for example, individuals can evaluate stimuli or stimulus even when they are not consciously aware of it. So you can prime subjects. You can prime subjects with, visually. You can ask subjects to, in simple experiments, you can ask subjects to identify facial expressions, human faces with specific facial expressions, or just human faces with neutral expressions, whether you like them or whether you like them or you don't, if you were to undergo such an experiment or participate in such an experiment. But what experimenters can do is they can add information that precedes a given picture or a given picture of a human face before you decide whether you like it or not. And that is called priming. And that would be, that it would happen in a split second. And for human beings who participate in such experiments, they just see a flash of light. They don't know what it is because it's flashed so quickly. So they can't identify exactly what they're looking at. So let's say, you can tag human faces with a picture that is scary. Let's say a werewolf or a zombie, a bloody zombie, a gruesome looking bloody zombie. And you can tag pictures with, or you can prime pictures with something pleasant, maybe a picture of a cute dog or cute kittens or a cute baby. And in this way, you can prime participants. And then, after such experiments, you can see that the priming actually affects the judgment, whether participants like human faces on specific pictures, whether they find them pleasant or unpleasant, whether they are likable or unlikable. And pictures that are primed with something negative, scary, or ugly, especially when something is scary, are more often than not categorized or identified as unpleasant or unlikable. And the opposite is also true. So based on such experiments, priming works, and it works at the subliminal level. So you can influence human judgment with subliminal information. So it works in such a visual experiment, or perceptual experiment, that is, but it does not lead to subliminal persuasion. So for example, and you will read this in the book, there is no results from 16 experiments showed no powerful enduring influence on behavior. Not one of the recordings, let's say if you play subliminal recordings to people who want to quit smoking, that smoking is bad and that starting tomorrow they will crave smoking less or drinking less, or that you are intelligent and smart and that you will do very well on your next quiz or test. That does not yield any positive results or correlations between subliminal messaging or persuasion with test results, or quitting smoking or drinking. Okay, so there's a difference. There is a stark difference between subliminal sensation and information processing and subliminal persuasion. It turns out, based on empirical data, that you cannot persuade people through exposing them to subliminal information for shorter or longer periods of time. So not one of the recordings helped more than a placebo, which works only because we believe it will. So again, the placebo effect is the effect that we believe something will be the case based on our expectations. So for example, in experiments, simple experiments on painkillers, the placebo effect is quite powerful. And for example, in experiments where participants are given a pill and it's a placebo, that is, it's not a painkiller, but it's just a pill that looks like a painkiller, but it's just salt or sugar, something really neutral or innocuous. But it's given by a person that looks like a doctor, or who says that this will help you to alleviate pain. After an hour of digestion, about 30 to 40% of participants claim that they feel better. And this is basically based on expectation that a patient is in a professional setting. He or she is given a painkiller by someone who represents the healthcare system, like a doctor or a nurse, or whoever it may be, and that leads to specific or triggers specific expectations. So the placebo effect is very well documented, and it works because we are highly suggestible creatures, and that is based on specific expectations that we have. Any questions here? So the other phenomenon which allows us to distinguish stimuli is difference threshold. And it's the minimum difference between two stimuli required for detection 50% of the time. So individuals experience the difference threshold. As just noticeable difference. So according to Weber was the first person to calculate this, to notice this and then calculate this for various senses. Two stimuli must differ by a constant minimum percentage to be perceived as different. So the exact percentage differs based on stimulus. Okay, so it will be different for vision, it will be different for hearing, it will be different for smelling and touching. but it will be constant for individual stimuli, sorry, individual senses, but it will differ between senses. So, for example, there needs to be a specific difference in auditory stimulus for you to detect that something is louder or not as loud. Okay, so if someone is driving a car and he or she is blasting music in the car, and there is a fire truck or an ambulance or a car behind them, then the sound that comes from the fire truck, the sirens that come from the police car or a cruiser or fire truck or an ambulance, has to be so loud, has to be even louder than the music that's being played in the car in order for it to be registered, in order for it to be noticed. Okay, so that is the difference. That is the just noticeable difference. It has to differ with a specific percentage. It has to be, in this case, louder to be detected by a driver in order to react accordingly. So this is true for vision, light, audition, sounds, olfaction, smelling, and tasting, and so on. There's another example that I want to show you from the text itself. Let me just go back to the book for a second. Oh, okay, here. So, for example, in the book, you have, this is also very well represented, the phenomenon of difference threshold is well represented by this example. And, you know, the size of font, the text starts with a specific size of font. And the question is, at which point do you notice that there is a difference in size of the font? Is it after 3 or 4 lines, or is it after 8 lines? So when I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, between 10 and 11, I can notice that there's a difference in size font, or basically size of the letters. But before that, I don't, because I cannot detect the difference. Okay, the difference has to be large enough, or has to change by a specific percentage for me to say, oh yes, now there's a difference between line 9 or line 8 and line 9 or line 10. So this is basically the same phenomenon with sound and smelling and touching and tasting. And this is why, for instance, when you go out with your friends and you are at a bar or at a club or at someone else's house and everyone is talking or the music is blaring, people are talking, and you're trying to have a conversation with the person next to you, you might say to them, you know, what did you say? I didn't hear what you said. Could you say that again? Could you speak a bit louder? It's because you can't detect the difference, because the background noise is so loud that the person that you're talking to is basically drawn out. It drowns in the sound, in the background sound. So he or she, when they are talking to you, has to speak so much louder by a specific percentage in reference to the background sound. Right? It's the same phenomenon.
Could it be explained as the moment when we can recognize the speech when someone else is speaking about one's or name of myself, or name of me, such as when that happens, you can be distracted from the noise, right?
Yes, you can. Yes. And it's a unique phenomenon because it matches your, the information matches what you consider to be self-specific, or what's called self-reference. So information that's self-specific or it's self-referential plays a more important part in your psychological makeup than other information that's not related to the self. So if someone all of a sudden says your name in a crowd of people, but they're not referring to you, nevertheless, you will perk up, right? You'll be like, oh, someone is calling my name, right? And you turn, but not to any other information, right? That is true. But in this case, it's a different phenomenon than the decibel level of information or sound, or the level of loudness. Because here you are turning attention to information that is very familiar to you and that you have grown to recognize very quickly, which is your name, right? So it's not about the level of sound or the level of decibels. It's not about the amount of light or whatever it may be. It's about self-reference or information that you are quite accustomed to and react very quickly to. Yeah, that's a good question, but there's a difference in the two phenomena. So yes, detection of difference between stimuli is called the Weber's law, because Weber was the first to identify it and then calculate the percentage the percentage of in which the two stimuli or one stimulus has to be different from the other in order to be detectable. Yet another sensory phenomenon that we experience on a regular basis is sensory adaptation, and we basically adapt to sensory information, whether it's pressure on our hands, whether it's light through the eyes, whether it's sound or music through the ears, or something that we taste, or something that we smell. So, simple examples: when you meet someone first and they have perfume on, you will detect it very quickly, and you will detect it as quite strong. And in the first few seconds, you might say, or a minute, you might say, oh, this perfume, even though it's nice, it's quite strong. I don't know if I will be able to, I will be able to sustain this conversation for too long. I feel like the smell is too strong. I might have to move a little bit farther from the person, even though I don't want to, or it might look bad on the receiving end of your friend or a stranger. It might be too much. The smell might be too much. But what happens after a few minutes, you adopt your sensory, the different sensory modalities, in this case olfaction, smelling, adopts, and it's not as stimulated, it's not as sensitive to the information, and you adapt to it, therefore it doesn't bother you as much. Okay, it's the same phenomenon for when you spray perfume on your body, or aftershave for men, and then at first it hits you really hard, you become quite sensitive to the smell, and then after a while you don't even notice that you have it on, even though other people might say to you, oh, that is a nice smell, or that is not, or that is or not so nice, or not so pleasurable. That is for others, and so other people will tell you that you have a strong smell, or that you emit a strong smell, or that you have something on you that has a strong fragrance, but you no longer do so, because you are the one who was exposed to the smell, and you grow and you develop this adaptation pretty quickly. And I'm sure you have noticed this phenomenon many times in your life. So this is basically, sensory adaptation, and it works for, anything that you might be wearing on your hands. So now we're used to wearing masks on our hands. You can put a mask over your hand, and you can feel the pressure of the rubber band around your arm, around your forearm or your bicep. But after a while, you no longer detect it. You no longer sense it, that it's there. You actually forget that it's there, right? And the same thing could be with a hat that fits snugly, or it fits tight on your head, or it exerts some pressure in the front, or in the back, or in the front of your head. But then after a while, you don't detect it anymore. You don't feel like you have it on. It's the same thing with glasses. You put on a pair of glasses and you feel them on your face, or sunglasses, but then after a while you don't feel them at all, right? So that is basically sensory adaptation. Any questions here, or any maybe simple examples or interesting examples from your life where this rings true? So Jen, you're laughing, but I'm assuming that you have something funny in your head, but it might not be suitable for sharing with everyone, yes?
Well, if you are living in a dormitory and a boy, then you probably agree that we are not the kind of people that usually
Are quiet?
smelling good, right? I
Oh,
mean,
okay.
yeah. So when you left your room for a while and come back, then you can smell that stink in your
Oh, yes,
room.
that's true. That's true, right?
Yeah.
You can smell the odor in your room or on your clothing. Yes, that's true. Yeah. And it happens, even if you're not in a dormitory, you can go to the store and come back, right? So that's why it is important to open the window, because we are basically marinating in our own smell or odors on a regular basis. And that's natural, and that's perfectly fine, as long as it's not too much, right? Yes, some people smell very well. Some people smell like roses all the time, right? Okay, so that is actually a very good example, right? Where you leave the environment of adaptation, and then you leave that environment, and you come back to it, and then you can notice the difference. Okay, so it's the same thing for vision. It works the same way for all sensual information. And I don't know if you know this, but this works very well with vision as well. And I think you perhaps have noticed that our eyes adopt to specific information, and when our eyes adopt to specific information, they move very quickly. So really, your eyes jitter. Your eyes jitter all the time. Okay, so the eyeballs move all the time in order to stimulate different parts of the cells that are in your retina. So because what happens is that when you overstimulate a specific cells in your retina, they habituate, or they don't work as well, or they are not as sensitive and fail to register or trigger conscious experiences. So you could say, in other words, another way of looking at it is, you can say receptors and nerve cells that process information from receptors tire, and when they tire, they stop working. So in order to stimulate the retinal cells in the back of your eyeball, the eyeball moves all the time very quickly. It jitters, so that not one set of cells are being used all the time. Because if that were the case, then they would habituate very quickly and then grow tired and stop working. And so you wouldn't be able to see. You wouldn't be able to see the various visual information that you enjoy on a regular basis. So you can create an apparatus that tracks the movement of the eye, and subjects who undergo such an experiment lose track of specific visual cues or information. Okay, so faces are become missing, or bits and pieces of information from faces, or visual cues such as visual representations such as heads or faces become incomplete. There's an element of whiteout in them, and other figures like triangles lose their shape, and you can show this to be the case with any visual cues or any visual information. The other really interesting thing that relates to this phenomenon, or the phenomenon of adaptation, is that even though your eyes are moving all the time, or your eyeballs are jittering, you don't experience your visual field to be jittering at the same time. So you could say, well, if the eyes are moving, then my perceptual field, or if my eyes are jittering, then my perceptual field should also be jittering left and right, or up or down, right? But in this case, it's left and right. But that's not the case. So here's another really good example to show that there's a difference between sensing, or even earlier, there's a difference between sensory receptors or sensory apparatus and what we perceive, right? So in this case, your sensory apparatus is moving, but the picture that you enjoy, in this case, a visual picture, does not move. Okay, so the brain basically creates or constructs a perceptual representation that is different from the information that sensory receptors collect. Okay, so the world that you enjoy, the psychological world, or the world of your consciousness, is not the same, or is not identical to the information that the different sensory modalities collect on a regular basis. The two are different. They're not identical. The two are really different. Okay, they work together, but they are different. Okay, so in other words, the world that you see and hear and smell and taste is not the same world objectively. Okay, what you see, what you experience is heavily constructed and heavily influenced by the way the brain has been structured through evolution, and by the way the brain functions. The different parts of the brain function together to generate conscious experiences or perceptual experiences or olfactory experiences or other, auditory or gustatory experiences. Okay, that is basically in many ways constructed. It's not a one-to-one ratio representation of what the world is like outside. So if you want to, when you go to a movie like Matrix basically plays on this idea that the world around you is different. Okay, Matrix, of course, the movie Matrix and other movies like that exaggerate basically this idea, but to some extent this is true. Okay, that we live in a world that is different from the world that it is objectively, because of the way we are structured as species, as organisms, and because we have the brains that we do. Therefore, other animals and other insects see the world differently from us. Some animals and some insects might see the world similar to us, but other animals and other insects see the world differently to us. They have access to different information. They have different thresholds, okay, for light, for hearing, for smelling, and for touching. Just gonna look at the clock. Any questions on this point? Okay, so let's take a 10-minute break. And because I think it's been 1 hour, and we'll come back soon and continue.
Hey, sorry, I actually just had a quick question.
Sure.
Hello?
Yes, yeah.
Yeah, just based on the quiz, that we have coming up due on the 10th.
Yes.
So you said it's based off of, sorry, I'm just pulling it up at the moment. So it's basically everything that we're learning today, put the biology and psychology and state of consciousness. Is there anything that should we be referring to the textbook as well, or just the slides and
No,
lecture?
it's all, yes, it's always textbook and slides together.
Okay.
Yeah.
So just reading both the chapters from the textbook and the slides?
Yes.
Sounds good.
Yeah. Okay. I'll be back soon. Zoom recording. Oh well, I guess for those who are not present today, we'll just have to rely heavily on the book. My apologies, but I also make mistakes. I'm only human after all. All right, jokes aside, let's get back to feature detectors, very important stuff. Okay, so this is, it's part and parcel of how vision is constructed and all the beautiful things or all the ugly things or just the plethora of wonderful things or array of different things that you enjoy on a regular basis as through your visual modality. And then there are also supercells, you could say, that gather that information and represent it more holistically. They basically allows for recognizing specific objects in more detail. Okay, so this you know, athletes do this on a regular basis in games, and some are very quick at detecting, you know, what to do in given situations, and some athletes rely on very small bits of information that then is processed by, for example, parts of the brain that that are identified with supercells, or the cells that are, let's say, in the fusiform area, for recognizing human faces or other maybe other images that are richer than typical images, or pieces of information that are characterized by only angles or edges or movements, and allow for a more richer, more holistic representation. Okay, so athletes do this on a regular basis. We do it on a regular basis too, but perhaps maybe not as quickly as some athletes, and maybe to some extent, apart from physical abilities, that is what, and training and dedication, that is what differentiates professional athletes from regular people. Sometimes the reaction time is a little bit shorter and maybe just more acute. So here is about visual information, processing visual information about the opposition, movements, you know, what is happening. And of course, this also is coupled with experience. Hockey players play on a regular basis. Soccer players, baseball players, basketball players play on a regular basis, so they have specific habits. They are attuned really to their environment, and experiences have made them better at what they do. But we all use this ability to a larger or lesser extent on a daily basis. And because we have specific cells, we have specific representational maps and specific cells in our brain to do so. So we also engage in parallel processing. While one part of the brain processes one type of information, a different part of the brain or different representational maps will process other kinds of information. So we call this parallel processing. And basically involves processing many aspects of a problem or scenes at the same time. And it's the brain's natural mode of information processing for many functions, including vision and other senses. So damage to a neural workstation due to a stroke, for example, may render a person unable to perceive movement. So there are specific pathologies that show that this is the case, because on a regular basis, you are not conscious of parallel processing. You're not basically conscious of the neural mechanisms or pathways or representational maps that are at play, because they're unconscious and they're working together to give rise to specific conscious representations. But with, for instance, if a patient suffers damage to a visual area in the occipital lobe, that's called neuronal area in the occipital lobe, that's called MT5V, if I'm not mistaken, MT/5V. So visual area number 5, then patients suffer from motion blindness. They are unable to perceive motion. So if you ask them to pour water or tea into a cup, they won't be able to do that. Because for them, what they see is, they see the world, or they see what we see as movement, they see in on and off snapshots. So picture 1, picture 2, picture 3, picture 4, but they don't see a smooth or seamless transition between snapshots of pictures, if you will, like in a movie, right? So we do this on a regular basis because, and you could say effortlessly, because our brains are working, are healthy, are functioning normally or just fine, but specific damage to specific brain parts will knock out specific specific abilities that we have, in this case, perception of motion, and this unfortunately becomes proof, empirical proof, you could say, that the brain processes information in parallel and then integrates information so that we have an integrated, holistic, conscious experience of the world around us, not in bits and pieces or fragmented all over the place. Okay, that does not happen. And the beauty of visual conscious processing, but not only visual, just consciousness in general, is that everything that takes place in consciousness is integrated and it works together as a whole, as opposed to being fragmented and all over the place in a kind of staccato on and off manner. That's not the case. So you can thank your brain for doing this in an unconscious manner on a regular basis. You know, it's really a wonderful machine, a wonderful biological machine. So pathologies such as motion blindness will exemplify very nicely, although unfortunately for people who suffer from it, that the brain processes information in parallel and then integrates information very, very quickly, so that we enjoy on daily basis, or you know, in split second to split second time frames, a seamless or holistic visual representation. But it's not only visual representation, it could be representation of a song or a melody, right? When you listen to a song or melody, or when you listen to someone sing, or when you sing yourself, or when you have a tune playing in your mind, it's not chopped up. It's not, you know, it's not fragmented. It's uniform. It's you can detect the melody because it is uniform and it's intact over time. Otherwise, you wouldn't be able to enjoy the song, and otherwise you wouldn't be able to enjoy rhythm. Okay, this is possible because of the way the brain is wired up together. So if you knock out perception of movement, you don't knock out all the other features of your perceptual field. That is color, feature detection, and so on. But so that stays the same, but you just knock out perception of movement. Okay. So here's another example. So really the brain, when it comes to vision, for example, divides, it works in parallel. So it runs 4 different streams of information processing: for motion, form, depth, and color. And it integrates all these different streams of information, or parallel functional processing, processing very quickly, so that you can enjoy a holistic and stream-like fashion of conscious experiences. And by stream-like, I mean that is seamless, that is not fragmented in space and time. And even though we know quite a bit from psychological sciences and from neuroscience how the brain works and how it represents information and how it puts information together, the jury is still out. We don't know how the brain produces consciousness. We don't know exactly how the brain integrates information and what mechanisms in the brain really fine-tune our conscious visual experiences so well not only visual, but other experiences as well, so well, so that it is not fragmented in space and time. We know that it's related to the brain, and we know that it's related or correlated with specific brain mechanisms and brain parts, but how it all comes together, we don't know. And that is definitely a project, a worldwide project that many researchers work on around the world right now, to figure out how brain gives rise to consciousness and the different features of consciousness that we enjoy on a regular basis. So what is in your visual field or visual information processing? Here's a quick summary. So we have the scene and the environment. We have retinal processing, receptors, rods and cones. Bipolar cells send information to ganglion cells, then that form the the rich fibers, neuronal fibers of the optic nerve, that then goes to optic chiasm, and then to the thalamus, and then to the visual cortex or the occipital lobe. And we have feature detection. The brain detects cells, specific cells to detect specific features such as edges, lines, and angles. The brain also uses parallel processing to construct the visual field or auditory field that you enjoy. And then there's quite a bit of recognition involved. The brain interprets the constructed image based on information stored from memory. So you say, oh yes, I remember this person. Or you say, no, I don't remember this person, because there's nothing in the memory bank to draw on, to identify, okay? And you recognize songs and tunes, and you recognize faces, and you recognize people, from the past, or smells or odors from the past that have been lodged inside your brain in specific parts of the brain responsible for housing memories. And then when you see something, and when you smell something, and when you hear something, it triggers that memory very quickly. And when you are aware of it, you say, oh yes, this brings back memories. This brings back memories, or specific points, specific time of your life, or specific days, experiences, and specific categories of information. Or categorizations. So recognition and interpretation is really the last process in this complex but very quick information processing stream, with various stages working together to give rise to the seamless visual or auditory or otherwise information you enjoy consciously. So there are specific perceptual, our visual field is heavily organized, as you can see by now, heavily detailed and heavily organized. And there are specific principles that operate or work in order to organize perceptual information. So principles of form, depth, and perceptual constancy, without which we wouldn't be able to enjoy the rich plethora of visual information that we do. So Gestalt is just means whole, and it refers to a school of German psychologists who first outlined the way we formulate or group information in order to categorize it and recognize it. So there are different tricks that the brain uses to do so. So a gestalt basically refers to an organized whole, perceptual organized whole, or perceptual whole. So we have this tendency to integrate pieces of information into meaningful wholes. And all of this speaks to many things that I have said today earlier. Interpretations during context, with the use of context, with the use of motivation, with the use of memory, and with the use of emotional coloring. Okay. So our brains do this on a regular basis, really, second by second. So here, right, I mean, objectively speaking, you see a Necker cube, right? So, but really the Necker cube, we have the Necker cube here in 3D, is you have the suggestion of a Necker cube. Your brain fills in the rest in order to represent a whole image. And if you look at the X here, relatively in the middle, it breaks down the image. You can see that, the 3 lines cut through a blue circle. But then these 3 lines, if you zoom out and if you take in the entire image, if you look at the other angles of the Necker cube, construct one side or one angle of the Necker cube. So you kind of, this is called bistable perception. At 1 second, you see the Necker cube and then you lose it, and then you see it and then you lose it. Okay, so this is basically your brain on and off on a regular basis, imposing form, imposing a specific interpretation onto bits and pieces of information that it is exposed to. And this is called the gestalt. Okay, we see things in wholes working together as opposed to fragmented. Because there is an advantage to interpreting the world in wholes from an evolutionary perspective as opposed to in pieces, because it allows for a quick decision making. It allows for a quick decision making for animals, recognizing predators or prey or something that is a friend, a foe, or a friend in the environment. So for an animal to make a quick decision whether it should hide, run away, or be relaxed. Okay. Otherwise, if animals were not able to do this more or less accurately, because we all make mistakes, as I have pointed out to you previously with this heuristic, this is also called a heuristic, thinking heuristically, very quickly, and making judgments very quick on small bits and pieces of information. If that wasn't the case, if animals did not, or animals like human beings, or let's say rabbits or dogs or snakes or other insects, if they were not able to do so relatively quickly, then they would get into trouble, or something would eat them, or they wouldn't be able to survive. They wouldn't be able to hunt, for example. They wouldn't be able to get away from predators or hide from predators. Consider an example. Let's say you are in the woods, you're walking through the woods, and all of a sudden you see an animal, and very quickly you think that it's a bear, or you think it's a wolf. So if you have a quick interpretation that it is a dangerous animal, then you will have an emotional reaction and you will be motivated to make a quick decision, either stay or get out or run, right? And then the emotional decision, the emotional reaction is a motivation to act very quickly. And I will talk more about this when we talk about motivation and emotions. So that is a quick assessment, quick judgment. a quick gestalt of what it is that you are looking at, a quick interpretation. But that doesn't mean that you're going to be correct, let's say 10 out of 10 times. But it's enough for you to be correct 6 out of 10 times, because that percentage allows you to survive. Consider the opposite. Consider, well, what if you stay there and you wait? You want the animal to get a little bit closer so that you can determine exactly what it is. Well, if you wait 5 or 10 seconds longer, your life could be in danger. Okay, so it's about quick decisions, and in order to make quick decisions, you need to have a specific visual field that then is interpreted in a specific manner by the occipital lobe. So that is why we enjoy gestalts, and we view the world in holistic manner, as opposed to in a typically, no, not typically, but in a fragmented manner. And that is why you can see the Necker cube. Sometimes you see it and sometimes you don't. But your brain imposes order on basically the information that is objectively available to you through in the world and then through the sensory receptors. It's basically making meaning, making sense of the world around it. A given organism like human beings, or rabbits, or snakes, or dogs, or birds. So small pieces of information here, just, you know, blue circles with 3 lines in it, but when organized in a specific manner will give rise to a whole different world, a completely different perceptual experience. Now the other principle is figure ground and grouping. So for example, grouping, we group things together in the visual modality. So what is proximal, we categorize together. So 1, 2, 3, 4, 5, 6, we have 6 lines, but because 2 lines are closer together than 2 other lines, then we group them together. We say there are 3 sets of 2, as opposed to 6 lines, okay? So here we see proximity. What is proximal is together. Here we see continuity, even though there is, you know, there is, you can say, is a wavy line that is cut with a straight line. So really we have just, you know, this picture is, or this visual experience is composed of various lines. But because we have the evolutionary advantage to interpret our world in a specific way, either in terms of proximity or principles of grouping, such as proximity, continuity, and closure, we don't see just bits and different lines stitched together. We see a pattern. Okay, we see that there's a wavy line and that there's a straight line, not not lines, really basically fragments of lines stitched or glued together. That's not how we experience it. And it's the same thing for closure. Right here, we can you can see the way the almost complete circles relate to each other. You can detect that there's a triangle inside, and that is the triangle. The perception of a triangle, or the expectation of a triangle, gives rise to a whole, a perceptual whole. And in this case, it's closure because it's enclosed. It becomes one unit. So Gestalt principles, Gestalt psychology is mainly interested in studies and catalogs the different principles, the different grouping principles that function in our visual modality, or conscious visual perception. So the figure ground, oh, sorry, that's depth perception here. But the figure ground, just to go back there, you know, really without the figure ground ability to see what's in the foreground and what's in the background, or vice versa, you wouldn't be able to detect human faces. You wouldn't be able to detect depth perception. We need figure ground perception in order to function in the world. Otherwise, we would be really confused by the amount of visual information we collect on a daily basis. So figure ground distinction allows us to pick out specific features or specific holes. For example, let's say human faces in the background of something else, or in the background of other faces. You know, we're able to identify trees and buildings in the background of other, or in the background of other information, such as other buildings and maybe the sky. You know, when a plane flies or shoots through a sky, we can pick it up pretty quickly and we can identify it even though in the background there's other information, such as, you know, the rest of the sky, different colors, different structures such as clouds, and so that is the, you know, it wouldn't be possible without figure ground perception, or the ability to divide a perceptual field into figure and ground, figure ground relationship very quickly. And on top of that, we have the principles of proximity, continuity, closure, depth perception, okay? Ability to see objects in 3 dimensions around images that strike the retina are 2-dimensional, okay? So the information that strikes the retina is 2-dimensional. But because we have the brains that we do and are hardwired for depth perceptions the way we do, even though we need to, even though infants from day one require experiences, so stimuli from the world in order to crystallize or to form specific connections, brains are hardwired for specific types or forms of perception, and depth perception is one of them. So this is basically painted on, and you can see that the crosswalk, the lines in the crosswalk are in 3D, and this has been done specifically on purpose, that is, or intentionally, to avoid for drivers to slow down, so that there are less accidents on the road. And, you know, 3D allows us to perceive various things, but you know, allows people to judge distance and shapes of various types very quickly. And if that were not the case, then we would live in a 2-dimensional world, and the world is not 2-dimensional; it is 3-dimensional. So the nervous system and the occipital representational maps that we have, in some ways, not in a one-to-one or not in a perfect manner, reflect what is objectively true. So in order to exist in the world of depth, or 3 dimensions, or 4 dimensions if you add time, then we also need nervous systems that, to some extent, more or less accurately, will represent the environment that we live in. Otherwise, organisms would die. They wouldn't be able to survive. So here's an experiment, the visual cliff, to test whether babies innately are hardwired for depth perception. And when you pair up parents with babies, and parents start gesturing, motivating, and calling for their infants to come to them, many of the infants are afraid to cross the quote unquote visual cliff, just an illusion of depth in front of them, because they recognize that it is innately, they recognize that it is dangerous. Some babies cross, but quite a few more babies, more infants than not, do not cross, even though they're being called by their parents, whom they trust. So another reason, so another example of how human brain, the kind of forms or the kind of processes the brain uses to interpret and construct the visual information, our visual information, or the information that we enjoy on a regular basis. This is just another example of this. And not just of that, but also the fact that certain abilities that we possess as creatures moving in an environment or living in an environment are innate, are basically genetic. And they find expression as infants grow, or as embryos develop in a uterus, and then as infants grow, we become better at specific tasks, visual and auditory tasks, through experience, because experiences fine-tune our abilities, but the ability to see in three-dimensional, to see the world in three dimensions is innate, is genetic. We inherit it from our parents. Okay, let me just see what the, okay. All right, so let's end it here because it's 11:20. I'm just going to leave 5 more minutes or so for questions. Do you have any questions?
No, thank you.
Okay. Do I get any questions? Okay, so we've gone through quite a few, quite a lot of information. The rest I leave to you to read and study in the chapters. But the quiz is going to be basically based on the biological continuation of biological psychology. Most of the bits that I covered under consciousness and states of consciousness. There's another lecture note on specific states of consciousness, and there are specific videos under week 5. So go through that, and then perception and sensation, which is today's lecture, and I think it's chapter 5 in the book. So again, in the quiz, you will get a list of terms, concepts, and it's a task of filling in the blanks. And this time I'm giving you more time. I'm giving you 2 sets of 2 hours. So you get 2 hours per one try, and then 2 hours per the second try. So I think that should be plenty to study and to perform well. And then test number 1 after the break, after your engagement week break, will be on everything that we have covered so far. So what is psychology, and critical thinking, scientific thinking, biological psychology, sensations and perceptions, and consciousness. Excuse me. So basically go back to chapter 1 and start rereading and studying from chapter 1 for when we come back after the break, and that's when we will do test number 1.
Wait, hold on. You want to say that one more time? So we just gotta read from chapter 1 until now. Just that's for the upcoming test.
Yes. Yes. So the book provides you with questions, test questions, so you can practice, use that. And I think at the end of each chapter, you also have a glossary of concepts. So that is a good way to keep track of the various concepts that you read through and that we have gone through. Of course, in lecture, we won't be able to get through everything, but that
Are we
is,
gonna, sorry, my apologies for interrupting. Do
Yeah,
we
go
have to do the test through like the book? Like I know that there's some, what's it called again, courses that are like that, or is it just straight through the, eCentennial?
no, the book itself will have, I think it already has set up a practice test for you. So yeah, look for that. And the book also has, at the end of each chapter, it has practice questions that will be similar to the questions, not identical, but in terms of content and information or definitions, will be similar to questions on the test. But I will also send you more information about what to expect for test number 1, so that you can prepare even better. Between now and the next couple of days, I will send you more information. But the book has quite a few resources, and at the end of each chapter, and it also has a test bank, if I'm not mistaken, with practice questions. I will double check that, but the few days, sorry, at the beginning of the course when I checked, I did see that. So hopefully you have access to that. But I will double check and get back to you.
Well, I'm sorry to say this, but may I leave this class because I have to learn about Thales theory. Everything is water.
Okay, all right. Okay, we're out of time. Thank you very much. And yes, study hard and sleep well.
Bye, Professor. Take
Okay.
care.
Okay.